Okay, hi everybody. So today we're going to go over episode 4 of 5-minute math, and today we're going to go over the arithmetic mean, geometric mean inequality. Okay, so arithmetic mean. What is an arithmetic mean? Well, that's the mean that you normally think of. You add up how many things you have, and you divide by how many you had. So if you had 2 things, it'd just simply be x plus y all over 2. If it was 3 things, you'd be divided by 3, and then so on. Okay, geometric mean, this is less common, less commonly known, but geometric mean is instead of adding them together and dividing by how many you had, you're multiplying them together and then taking the nth root of how many you had. So if you had 2 things, you take x times y and you take the square root of it. If you had 3 things, you take x times y times z and you take the square root of it. Okay, sorry, the cube root of it, because I have 3 things. Now, what is the arithmetic mean, geometric mean inequality? The arithmetic mean is going to be always greater than or equal to the geometric mean. Okay, let's do a quick example. So say you had 3 and, well, I don't know, 4. Okay, so 3 and 4. So the arithmetic mean is 3 plus 4 over 2, which is 7 halves, which is 3.5. The geometric mean now is the square root of 3 times 4, which is the square root of 12, which is going to be approximately equal to what? 3 point something, and it would definitely be less than 3.5. Okay. Let me actually crank this out real quick with us. So the square root of 12, just to make sure, or just to show you, to convince you of it. So square root of 12. Uh, 3.4. Okay. So 3.46, which you can see is less than 3.5. Okay. So that's an inequality that we will be dealing with. Okay. So the first one we actually don't really have to use directly. We can actually avoid this a little bit. So what is the largest possible value of this? I want to make this as large as possible. So I'm going to deal with this using the properties of logarithms. So if it has division there, then I can rewrite this as using subtraction. So I have log base a of a minus log base a of b plus, and then we do the other one, log base b of b minus log base b of a. Now, hopefully you recognize that this is 1 and this is 1. So adding those two together, you get 2 minus log base a of b minus log base b of a. And then that gets to be the tricky part, like what do you do with those? Okay, so what I'm going to use is I'm going to use something called the change of base formula. So the change of base formula is this. If you have log base, say we'll just do we'll do b of a. You can change this into any base that you want, any base, by taking log of whatever base I want. I'll fill that in a minute, of the argument that I'm taking the log of, so a, all over log base, whatever I'm changing into, of b. Okay, and this is the change of base formula. Now, the other one has a base of log a, so I'm going to go ahead and put this as base log a there as well. So this turns out to be 2 minus log base a of b minus log base a of a all over log base a of b. Now, lucky for us, this is also equal to 1, this portion right here. So this gives me 2 minus log base a of b minus 1 over log base a of b. Okay. So now what? Okay, so now let's go ahead and we can factor out some stuff. Or actually, let's combine everything. So combining everything together, it is a least common denominator of log base a of b. So this is going to be 2 log base a of b minus log base a of b squared minus 1 all over log base A of B. Okay, just a common denominator between 1, 1, and log base A of B. Okay, now if you notice what's happening here at the top, we actually have a quadratic. So this is negative log base A of B squared minus 2 log base A of B plus 1 all over log base A of B. Now, we're dealing with a log function, right? So this is going to be positive. This up here, I don't know, but this negative here, I can factor this. This is actually quadratic. If you notice, you have the variable squared minus 2 times the variable plus 1. So you can factor this into log base A of B minus 1 squared all over log base A of B. Now, like I said, this is positive here. This is positive because I'm squaring it, but I'm taking the negation of it. So this whole entire thing has to be less than or equal to 0. So what I want to do then is I want to find the largest possible value of this. Well, the largest possible value of this would have to be 0, as long as I can make it equal to 0. And can I do that? Yes, I can, because this right here you can make equal to 0 by having A be equal to B. Okay, so 0 is the largest value that this can take on. Okay, the next one. Let x and y be positive real numbers such that 4x plus 9y is equal to 60. Find the maximum value of xy. Okay, so here's where I'm going to use the arithmetic mean, geometric mean inequality. Okay, so this is what it states. So I have these two things here. I'm going to go 4x plus 9y divided by 2. Right? That's the arithmetic mean of those two things. I know that this has to be greater than or equal to the square root of 4x times 9y, which is equal to the square root of 36xy. There's the xy, which is equal to 6 times the square root of xy. So let's kind of go back and regroup here. Well, what is 4x plus 9y? 4x plus 9y is 60. So 60 over 2 is 30. Has to be greater than or equal to 6 times the square root of xy. Divide by 6, you have 5 is greater than or equal to the square root of xy. So 25 has to be greater than or equal to xy. So 25 is the answer. Okay. It does go a little bit. That's kind of like a little bit of hand waving. Actually, I know that's the bound for it, but I actually don't know that that's the lowest value. But in these competitive style math questions, like quickness is essential. And most of the time that I've seen these, they're always just whatever that lower bound is going to be. Okay, so 25 is the answer there. Okay, so hopefully you guys understood that a bit. Good luck with the questions on the homework, and I will see you in the next episode. Bye, everyone.